REDtalks.live. I am your host, Nathan Pierce from F5 Networks, and with me, another guest from Aspen Mesh. This seems to be where a lot of the great minds are right now. I have with me Neeraj. Neeraj, say hello to everybody.
Hi, I'm Neeraj. I work for Aspen Mesh, which is an F5 innovation, and we are focused on bringing an enterprise-grade supported service mesh offering to market.
Now, Neeraj, you're in Boulder, Colorado, am I right?
Yes, I am.
All right, let's play. Where is it colder right now? California's got a bit of a cold freeze going on, and it's like 40 something.
Where are you? In Seattle, right?
No, I'm in California.
I'm in California. Hang on. So here it's 30, so we are colder.
Okay, you win. But we're having a cold freeze. It's not fun. That's not what we're here to talk about today, which the listeners are probably happy about. What we're actually going to talk about is tracing. Now, something that's very important when you need to know what's going on with my services that are, especially in these more modern microservice architectures where they're everywhere and nowhere all at the same time in very much a Schrodinger's cat style fashion. Is the microservice alive or dead? You're not looking at it, who knows? Tell me, what is this tracing? Let's just give a bit of background of why it's important before we go into some of the tips that you can provide for our listeners as to how to do it best.
Absolutely. So just like you mentioned, in a typical microservices environment, when a client makes a request to a front-end service, that service itself makes subsequent requests to other microservices, which can then themselves make more requests. So eventually what happens is you end up with a long chain of these requests flowing into your system. Now, tracing gives you the ability to understand the relationships as what outbound requests were made for which inbound request. It gives you an overview of the entire request lifetime, understanding the things like understanding latencies, if there were failures, and at the same time giving you the ability to zoom in and look at a particular hop if you want. So you get the whole picture at the same time, understand individual characterization of requests. So in microservices environment, I think you need something like tracing to actually understand what's happening.
So it's not just about, oh, something went wrong and I need to find out where the packets infinitely disappear to. I mean, it's also, like you said, there's performance-related things. What if actually when I trace it, I realize it went over there and it shouldn't have, and I had to come all the way back from over there, and oops, we've made it do bad things. So I guess it's not just break-fix kind of traditional tracing where we packet dump on a switch and just look at a stream. This is, you've got more intentionally volatile environments around you, and tracing actually is just general operations you need to be aware of, kind of how they're interacting and what's going on. Is that a fair description?
Absolutely, that's spot on. I mean, it's what I think of it is you need to characterize your system. You need to characterize your entire application, which is composed of various microservices, and tracing actually gives you that ability to understand.
Cool. I feel like I would have really done with this when I lived in England and I first moved there, and none of the streets are like straight lines like a lot of them in the States. After about 30 minutes, a bit of tracing would have helped me find my way home. That place is a maze. Anytime I'm trying to work out interactivity between containers, I think about roaming the streets of London as a tourist and getting very, very lost.
That's a very accurate analogy. I mean, it does get messy when you have so many of these containers running around, and many of them are ephemeral. So you might not even know that the request was made because then the container is gone. So
debugging something that instantiates and vanishes quicker than you can type the command, that's a tricky kind of task for anyone. Cool. So how do we go about doing this wonderful tracing?
So typically, tracing is done by propagating few headers. So let's take an example of Zipkin, which is an implementation, which is one of the first implementations of tracing. And what happens is when a service receives a request, it will add few headers like a trace ID, a span ID, and a parent ID. So then that service makes a request to a second microservice. The second microservice, when it receives these requests, it when it is ready to make further downstream requests, it will propagate these headers along. And as it is propagating these headers, the span ID and the parent IDs are changed so that you get a nice parent-child relationship. So typically, suppose if you have a microservice architecture with 3 services, say A, B, and C, your first microservice is A, it will create a trace ID, span ID, and parent ID. The request which reaches B will have a trace ID. The trace ID is kept constant throughout this chain, so you know all of these spans are tied together. Then when B is ready to make a request out to C, it will create a new span ID, make the parent ID as the span ID of the incoming request. And all of these information is sent back to a tracing collector backend, which can then batch and correlate and tell you that these 3 requests actually were meant for a single incoming request. So
interesting. And so, okay, injecting these kind of IDs that you can trace, if I understood right, you have like each instance has an ID it can inject, so you know almost where its last hop was, but there's also transition that you're tracking there. Is that right?
Yes, it is. So you are creating new IDs, and at the same time, you're propagating some information from what you received. So there's a correlation done. And then at the end, when all that information reaches your backend, like a Jaeger or a Zipkin collector, you have nice call graphs saying it hit A, then A made a request to B, and then B made a request to C.
That's cool. You get the whole, this is me saying I just touched it, and then this is the you touched it last ID. So that's cool. And I'm guessing that as part of this process, merely stamping IDs, that's one part, because I can, if I'm actually watching the traffic, say, okay, well, this thing has just come from here, and before that it was there. But there can be many different things strung together. So I should probably be logging these to some kind of state engine or something to the side, maybe a database even, so that I can map whole transactions back and forth.
Exactly. So that's what happens. So all of these small things are then eventually reported back to a database like Cassandra. And then there is a front end which can kind of give you a correlation and a nice view saying all of these things are related together.
That's cool. I mean, old school people, I know I look 21, but I'm actually quite old. Probably remember like looking at enterprise architectures, and there were companies that came out with these like packet tracing tools that could, from a central point would say, take a stream from the router, then some core switches, then some edge switches, and even pick up some packets out of a host, that the virtual machine's running on, and actually just show you that stream. And you could go like, oh, I want you to map port 80 from these ranges through to here to there. But that was fine because we were able to just pick a port off of physical devices like the router, the switch, and then the NIC sitting in the VMware host. But that world is gone. And those solutions now are just going to show me a 443 stream coming in, and then the spaghetti is totally invisible to that. And I don't mean spaghetti as in saying it's craziness. It's intentionally that. It's a mesh. But those solutions just won't work anymore. We need to be tagging at a service level, like what you're talking about, and not just a packet NIC coming out of a physical box of hardware, right? That's
absolutely, and that's where the concept of service mesh and Aspen mesh really takes off. You are tracking things at a service level. And are you hearing some echo?
No.
All right, so I was just checking.
Okay, sorry.
Now, so yeah, you are tracking these things at a service level, like you mentioned, and the old school method of understanding just through one port will just not work. And with Aspen Mesh and with Istio, actually, you have an additional benefit. Like if you're typically doing your own microservices, you will have to implement all of this on your own. You will have to embed into your application the logic to create trace IDs, creating span IDs, and then actually batching and sending the information up. With Istio and Aspen Mesh, you don't have to do most of these things. The benefit is you get a sidecar. The sidecar is your friend which lives in the pod and which will do all the heavy lifting for you. So in this paradigm, what it will do is when it receives a request and it does not have tracing information like trace ID and span ID, it will create that for you. And then when you're about to make a request out, as long as you transfer those headers, the sidecar proxy will then automatically create new IDs and make sure that you have a nice parent-child relationship and also send it to your backends. So the application is really free from doing all of this except transferring headers.
So then all I have to do as a developer is make sure when I'm making my microservices, it's actually just putting in that small amount of code that's like, okay, when stuff comes through, we're going to implement this tracing and we're going to use this sidecar service to give me the header to inject and to do the tracking of that for me. And it's a trivial bit of code that I can just insert in and then get back onto my functionality.
Absolutely. So the whole idea of service mesh, and especially in this context, is to take that burden and complexity away from the developer so that you are focused more on just your core logic and not all the other infrastructure pieces.
Now, you probably didn't know I was going to do this. I'm going to challenge you with an alternate solution.
Okay.
What we could do is have the developers send all of their logs to a big database, and then we can manually go through all of the individual logs of every microservice and string it together on our own independently. Why anyone would do it that way, I don't know, but that's kind of the alternative, isn't it?
It is. It's a really expensive alternative, and it's more cumbersome, and you might not even, because there is so much of data and all of that is not correlated, you might get actually lost trying to figure things out when there is much better structured way of doing it.
I totally prefer your way. That sounds much easier. And yeah, just using IDs and being able to string those together and you can see the exact path. That sounds much more sustainable. Yeah, totally. So I've got any examples of a kind of fault that would be much simpler to mitigate? I'm totally putting you on the spot here. I mean, definitely things like any kind of connectivity fault from service to service, or whether a service was able to discover what it needs to be able to perform the next function. I mean, imagine they're pretty crucial to have that traceable so that you can see, okay, 2-3% of the time we just hit a dead end. There's nowhere to go. Like, is that a good example?
Yes, that's a perfectly good example. Other examples where you can use tracing will be to actually understand the performance of the system. You want to understand why your overall latencies are high. Then you want to know which particular hop in your microservice chain is having most of this latency. And then you can go on to optimizations like building cache if it is possible for that service. So
so you're time stamping as you're showing the hop on the previous, and then that's cool.
Yep.
Yeah, I totally get that, because time is everything. I know how many websites I give up on in the middle of a transaction just because it took a little bit too long. In fact, these days, your brand association is very much related to that. The customer experience, it's not whether they answered the phone quick enough. I mean, if I take just a little bit too long to find the data I'm looking for, that's it. And I associate that brand from then on as the ones that didn't invest in their technology enough, because we'll go online first these days. Or maybe that's just the company that didn't put Neeraj's tracing in, and they should have, and they would have had me as a customer if they did.
Absolutely. Yeah. I mean, whichever metric is key to your customers and whichever is a differentiator, you need to be able to identify whether you are actually performing on those metrics, and tracing gives you that ability.
That's really cool. I like this tracing thing. I should really put some more effort into reading about it. Now, the cool bit for our listeners is, I know we've just had a bit of a chat about its importance today, is you actually put together a blog with a lot of details in how to implement this. Am I correct?
Yes, I did. And that blog is a interesting bit of information on a particular interaction when a few things come together. So a little background on why I wrote the blog. So I'm part of Aspen Mesh, and like I said, we are offering a service mesh product, but on our own production environment, we also use service mesh to actually deploy and get benefits like tracing and metrics and a bunch of other things like security from service mesh. So I started in our own applications propagating these headers. And that's where this blog came out, because I saw an interesting pattern where if you are using Istio or if you're using Aspen Mesh and you have the sidecar deployed and you want to add tracing, and if you're using any AWS services, it's not so trivial because of the way AWS client libraries handle these requests. And that's what the blog is about.
That's interesting. I guess with a lot of the abstraction we get from cloud platforms, be them infrastructure, PaaS, SaaS, abstraction's great from relieving me of things to concern about, but for tracing and debugging, it's also relieving me of some of the hooks I need to know what's going on. So that was kind of your driver of sort of looking into this.
Yep, absolutely. So we basically, in our application, we are hosted on AWS. We were making a bunch of calls to Dynamo. And I wanted to add tracing to characterize how much is my latency to Dynamo, how often I am hitting it. So as part of doing it, what I found very interesting was I was using the AWS client package. And AWS libraries by default will sign your requests. And they sign your requests, including the headers. So what was happening is my application was getting a request with a bunch of tracing headers. I passed those tracing headers along to a new Dynamo request, send them to the sidecar, and then the sidecar was changing these headers because it was creating new headers as child spans and maintaining the parent-child relationship. The problem was AWS library was signing these requests before it was reaching the sidecar, and then the sidecar changed them and broke the signature.
I can see how that might be kind of troublesome for you. Yeah.
So what happened is eventually these requests were going to the backend server like Dynamo, and they were getting all 400s because the signature was no longer valid. And it's like a typical, developer rant maybe, because I tested all of this in my own environment and it worked perfectly fine. And then when I injected the sidecar in my production, I suddenly see, oh, well, it's 400s because now my signatures are broken.
That's good. That's good. And we are REDtalks, ranching engineers and DevOps. We've had plenty of engineers, but it's good to get some ranting back, because I think a lot of innovation comes from first it's a developer just ranting about something they just went through. Absolutely. And what happens next is critical. Do they solve it and then just move on? Or do they share that with people and say, you know what, this drove me mad. I'm pretty certain it's going to drive someone else mad. We had your colleague Andrew on the other week showing how he was getting Minikube to run inside of a container because who wants to build up entire environments all the time? And I mean, this is great as well. You were having your own issues of, well, how do I know where that went? These magic 400s coming from something.
Exactly. So this actually gets better because of how I went about solving, and it took me a few iterations. So after realizing that the AWS SDK was signing these headers, I said, let me just add a custom callback, which will call me after the request is signed so that I will start injecting my headers after the signature. So then the sidecar can change it and the signature validation won't break. Perfectly reasonable solution, right?
Yeah.
That did work, and it just worked for the first request. And it actually broke for any retries. So it was a bit of an interesting case. I looked at the AWS package, the code, the client code, and it looked like in its retry mechanism, it was making a copy of the first request which was sent out, which now has my tracing headers. It signed it, and then it transmitted the signed request again for retries. which will break again because the sidecar is going to change those headers.
Oh, wow. So every time you solve the next step, there was just something new for you to work out. That sounds like a real fun project.
It was, I would say it was fun. And so then so that's where the progression happened. Like initially everything was breaking. Then the first request used to work. Then the subsequent retries will fail. So in my blog, I go through that. And then finally I present my solution, which looks a little weird, but it actually works. And that's why I wanted to share it and ask if people have better solutions. So what I do is, first I get the request signed by the package. Then I add the headers, add my tracing headers. Then the request is sent out. Then I remove those headers so that when it goes to retry again, it completes the cycle and it starts from the beginning.
Oh, that's brilliant. So you're doing the tampering and then the removing of the tampering so that you don't break the security feature of the signing that's making sure nobody's doing any tampering.
There you go.
Fantastic. Well, that just shows you need end-to-end validation of the signing and not transactional. But hey, let's not, that's a whole nother topic right there.
That's another topic. We will have some discussions on that in the future, I'm sure.
Well, you don't want them to do the end-to-end signing, otherwise your solution suddenly stops working.
So exactly. So I mean, the AWS package is very flexible in general. I was hoping they will give some ability to say, don't sign these headers, But that functionality was just currently missing, which would have solved this problem because you don't really need to sign the tracing headers.
Well, hopefully our friends at AWS are watching this and saying, hey, that's actually a really cool idea, because I'm going to be sharing a link to your blog in the article on REDtalks.live, within which this episode will be embedded.
Right.
The magic of iframes.
That sounds perfect.
Cool. I really appreciate you coming on and explaining this. I can already think through a whole bunch of things that this would have simplified that I definitely banged my head against the wall over. So I hope this really helps out a lot of other people. Again, I'm going to share a post to your blog. Your blog, I believe, does support feedback and comments at the bottom. I just got it over here. Yes, it does. So please, anybody, just, share your ideas, I guess, if you've tried to solve this in a different way. I mean, let's all try and work smarter and cleverer by sharing these kind of solutions.
Mm-hmm. No, that sounds great. And that's why I shared it, hoping that people will use it or provide us feedback and better solutions.
Awesome. Let's get it out there. I'm going to share this ASAP. Thanks for coming along, Neeraj. I really appreciate your time. Maybe we'll have you along again. I'm sure this isn't your first and last idea. So we'll speak to you again sometime, I hope.
Yep. Thanks, Nathan. It was a lot of fun.
Okay, great. Thanks for coming. You've been listening to Nathan Pierce from F5 Networks, your host on REDtalks.live, and my awesome colleague Neeraj out there in Colorado at Aspen Mesh. Thanks for listening.